My dear students, Assalamu alaikum. I hope you all are fine. Today I am with the lesson Disproportion reaction. From this lesson, the points to be learnt are oxidation, reduction, definition of oxidation number, calculation of oxidation number verbally, disproportion reactions, and finally we will see definition of disproportion reaction. So dear students, let's begin. First of all, let's learn oxidation, reduction and oxidation number. To know these, let's consider a chemical reaction between sodium and chlorine. From this reaction, sodium chloride is formed. Now this reaction is balanced putting half here. This reaction happens in two steps. In the first step, sodium donate one electron. Here loss of electron happens. This loss of electron is called oxidation. This electron is accepted by chlorine. For the sake of balance, this half is put here. Actually, there is no existence of half molecule of chlorine. So this chlorine molecule accepts this electron and form chloride ion. Here acceptance of electron happens. This acceptance of electron is called reduction. Now let's see, this electron and this electron will cut. Now sodium plus half molecule of chlorine here form sodium plus and chlorine minus, sodium chloride plus minus. So this is the molecule where sodium donates one electron and chlorine accepts that electron, and it is indicated like this at the top of the element and here at the top of the element. Sodium donates one electron, that's why plus 1, and chlorine accepts that electron, that is why minus 1. Now the definition of oxidation number. The number of electrons donated or accepted by one atom of any element in a molecule is called oxidation number. Let's see again. The number of electrons donated or accepted by one atom of any element in a molecule is called oxidation number. In this molecule, sodium donates one electron, so its oxidation number is plus 1, and it accepts one electron, that's why its oxidation number is minus 1. Let's move on to the next point. Let's see oxidation number of some compounds. This is sodium chloride. Here oxidation number of sodium is plus 1 and chlorine is minus 1, because in this compound sodium donates one electron and chlorine accepts one electron. Let's see here what is the oxidation number of chlorine. In this molecule there is a covalent bond and no chlorine atoms donate or accept electrons. So here 0, here also 0. Simply we can write the oxidation number of chlorine is 0 at the top of the molecule. Similarly, oxidation number of hydrogen is 0, oxidation number of oxygen is 0, and oxidation number of nitrogen is 0. Let's move on to the next point. Let's say electronegativity series and calculation of oxidation number verbally. Fluorine is the highest electronegative element, then oxygen, then nitrogen, then chlorine, bromine, carbon and hydrogen. Its electronegativity is 4.1. This is 3.5. For nitrogen it is 3.1, chlorine 3.0, bromine 2.7, carbon 2.5, hydrogen 2.1. Let's say electronegativity. From this electronegativity, oxidation number of some elements in the molecules. This is hydrogen chloride and its structure formula is this. This is a covalent molecule, so no donation and acceptance of electrons happen here, but its electronegativity is, chlorine's electronegativity is much greater than hydrogen, so electrons shift towards chlorine. That is why its oxidation number is considered -1 and it is +1. Similarly, let's say water. Oxygen's electronegativity is much greater than hydrogen. Oxygen 3.5, hydrogen 2.1. So electrons will shift towards oxygen. That is why oxygen's oxidation number is -2, this hydrogen +1, this hydrogen +1. That means oxygen -2, hydrogen +1. Two hydrogen atoms donate 1 electron each. That is why +1. And oxygen atom alone accepts that 2 electrons. That is why here -2. Let's see what is the oxidation number of sulfur in sulfuric acid. Oxidation number -2. There are 4 oxygen atoms and 4 oxygen atoms take total 8 electrons. Out of these 8 electrons, 2 hydrogen atoms supply 2 electrons, 1 electron each. Then left 6 electrons. These 6 electrons, sulfur donates these 6 electrons. That is why oxidation number of sulfur is +6. Let's see another example. Potassium dichromate. Here there are 2 chromium atoms, but definition of oxidation number is the number of electrons donated or accepted by one atom of that element in a molecule. So here no 2 atoms, it will be 1 atom in calculating oxidation number. Oxidation number of oxygen is -2, so total 14 electrons oxygen accepts. Out of these 14 electrons, potassium supplies 2 electrons. Then total 12 electrons left. That means chromium donates 12 electrons. Yes, but 2 chromium atoms donate 12 electrons. This is not the oxidation number of chromium here. Oxidation number of chromium here is +6. Each chromium atom donates 6 electrons. That is why here +6. Let's move on to the another point. Now the point is disproportion reactions and definition. Let's see some examples of disproportion reactions. First of all, chlorine gas reacts with water liquid, then hydrochloric acid and hypochlorous acid are formed. This is hypochlorous acid, Let's see oxidation number of chlorine here 0. We already knew the matter. And here oxidation number of chlorine is -1. And in this molecule, oxidation number of chlorine is +1 because oxygen is a higher electronegative atom. It accepts 2 electrons. One is donated by chlorine, another one is donated by hydrogen. So oxidation number of chlorine here +1, here -1, and in this chlorine molecule it is 0. So a total 2 chlorine atom with oxidation number 0. Out of these 2, 1 chlorine atom 0 to here chlorine -1. That means here accepts of electron. Chlorine accepts electron here, and acceptance of electron is called reduction. And another chlorine atom with 0 oxidation number here +1, chlorine +1. That means here donation of electrons happen, and donation of electrons is called oxidation. So this is the reaction where one element undergoes, this is reduction and this is oxidation. So one element undergoes oxidation and reduction at a time. So the reaction in which one element undergoes oxidation and reduction at a time or simultaneously, that kind of reaction is called disproportion reaction. And the definition is the reaction in which one element undergoes oxidation and reduction at a time. That reaction is called disproportion reaction. Let's see another example. Now the example is when chlorine gas is passed through sodium hydroxide at the temperature 50 degrees Celsius, then sodium chloride, sodium hypochlorite and water are formed. This is sodium hypochlorite. Here oxidation number of chlorine is 0, here -1 and here +1. Two atoms of chlorine with oxidation number 0. From these two, one atom is changed to chlorine minus, accepting one electron. Acceptance of electrons is termed as reduction. And another atom of chlorine with 0 oxidation number is changed to plus, releasing one electron, and loss of electron is termed as oxidation. So this is the reaction where chlorine undergoes oxidation and reduction at a time. So this is a kind of disproportion reaction. Let's see another example. Now the example is when chlorine gas is passed through sodium hydroxide at the temperature 70 degrees Celsius, then sodium chloride, this is sodium chlorate, and here water. If this reaction is balanced, then here C3 will come, here will come 6, here 5, and here 3. 6 hydrogen atoms, 6 hydrogen atoms. Now the oxidation number of chlorine here 0, here -1, and here +5. 6, 1. So here +5. Total 6 chlorine atoms with 0 oxidation number. Out of these 6 chlorine atoms, 5 chlorine atoms are changed to 5 chloridions, accepting 5 electrons. This is a reduction. And another 1 electron with 0 oxidation number is changed to chlorine +5, releasing 5 electron, and this is oxidation. Now this is the reaction where chlorine undergoes oxidation and reduction at time. So this is a kind of disproportion reaction. Let's see another example. Now the example is dissociation of hydrogen peroxide. Hydrogen peroxide is a kind of unstable molecule which dissociates to water and oxygen. If the reaction is balanced, then here there will be 2. Now the oxidation number of this oxygen is -1, because here oxygen's electronegativity is greater than hydrogen. Electrons will shift towards oxygen, so here -1, similarly here -1. So the oxidation number of oxygen in hydrogen peroxide is -1, here -2, and here 0. So total 4 oxygen atoms with oxidation number -1. Out of these 4, 2 oxygen atoms with -1 is changed to 2 - 2, accepting 2 electrons. So this is reduction. Again, another 2 oxygen atoms with oxidation number -1 are changed to oxygen 0. that is here releasing two electrons. Releasing two electrons is oxidation. Now, in this reaction, oxygen undergoes oxidation and reduction at a time. So, this is a kind of disproportion reaction. One thing is very much important to know, that is oxidation number from 0 to +1, +2, +3 and so on, and again -1, -2, -3 and so on. If oxidation number is changed from minus, then 0, then plus, then it is oxidation. And from plus to 0 and then minus, then it is a reduction. My dear students, no more today. Thank you very much. Take care.